Today we are going to immediately start on this question. So we're looking at the product of array except self. It's an array question and possibly also requires a hash map. Firstly, we are given an integer array nums and we're supposed to return the answer such that answer I is equals to the product of all elements of nums except nums I. Okay, and we are expected to have a linear time algorithm. So the first thing we look at, I think I understand this question. It's 1, 2, 3, 4. So 24 is the product of 2 times 3 times 4, and 12 is the product of 1 times 3 times 4. Yeah, 8 is the product of 1 times 2 times 4. Okay. So first thing we do is we look at this, and yeah, of course we have a number that is like that, and then when you traverse through the entire array, perhaps you could have a hash map of all the numbers. So one, what do you call that, nums, right? Nums 0, you have this, and then you have this, you have this. So first thing we're thinking of is something like that, possibly, and then this will of course be 1, 2, and 3. You have a hash map of all these values. Obviously this cannot be nums, because if this is the case, then there might be duplicates. For example, in this case of did they say that it must be unique? Integer array. Nope, they didn't mention that, but definitely there's a case where we can be unique. So for example, 1 and 1 might be repeated twice, and in this case we can't. So we probably have to use the index in this case, right? So if we use the index, it probably will be something like this. And then the next thing we would need to think of is what are we supposed to store, right? So for example, if we traverse through this entire array, we will need to multiply 1. Okay, I think I got the idea. So we initialize the array values with 1 throughout the entire we initialize the hash map, right? We have a product map, it's called map equals to this, and nums equals to this. You initialize this to this, okay? And then the next thing you do is you traverse through nums array, and when you traverse through nums array, every time you come to one value, you will multiply all values in the product map. Let me type it down. Traverse through nums, multiply all values of product map with nums I except the value at nums I, right? Traverse through nums, multiply all product values of nums with nums I except nums I. Okay, so in this case, let's see, right? So when we are at 0, what we will have to do is when we are at index 0, right, the first thing we will have to do is we have to increment all values by 1, the value. So you want to multiply it by nums 0, okay? All of them except for multiply by nums 0 by all values except for 1, right? And then you move on to 2. You move on to index 1. You want to multiply them all by index 1 except for index 1 itself, right? So again, you go through the entire array and then you look at it and then you multiply it by star nums 1, right? And then you multiply everything here except for nums 1 itself by nums 1. Okay, so this essentially is the basic idea. However, let's examine the time complexity of this solution. So the first thing is that so for looping through for each value in nums 1, 2, 3 and 4, we will need to essentially loop through all values in the hash map again. So when you loop through all values in the hash map, right, you will take n times. So you have to do the operation of n again. Multiply, right? So for the first element, you essentially have to go through the hash map 4 times. For the second element, you also have to go through the hash map 4 times, essentially. Do the multiplication element 4 times. So this is a O n times n solution, which is not ideal, obviously. So the next thing we have to think about is okay, so opt for any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must try without using the division operation. Okay, you must write an algorithm runs in O(n) time. So how can we write this? How can we do this? How can we do this? O(n) time without using the division operation. Times without using the division operation. Okay. How do you do this? One, two, three, four. How about we think about this as well? Okay, how about we modify this? So it's well, essentially we could also have an additional array. So let's say product array. and we initialize this to say 1 2 1 1 1 1, and then each time you multiply the entire array by 4 by nums I, right? So solution 2, right? You have 1 1 1 1 and then you multiply it by nums I. And then you divide, but you cannot use the divide. How do you multiply the entire array by a particular number? It's still O(n) time complexity. Yeah, it's the same, so this doesn't work. If we don't use a product map, what do we do? If we do not use a product map, how about obviously there is another one solution, which is just taking 1 and then a double for loop that will multiply 2, multiply 3, multiply 4, and then 2 to multiply everything else. Again, it's an O(n) times n solution, so that's not ideal. So essentially, the most important thing for me is 1 2 3 4 multiply by 4. What do we do? 2 multiply by 4. Okay, multiply by 4. How about we have again, I want to revisit the idea of having a product array, right? And we initialize this to once at the start, at the beginning. So with this product array, what we can do is to traverse through the entire array. When we are at nums 1, 0, when we're at nums 0, what do we do with this product array? We have 1. This, or could I have a 2-pointer solution? Alright, if I have a 2-pointer solution here, perhaps something like this, and then we have 1 and 4, and then multiply 1 with 4. And you move your pointer. No, this doesn't work. This does not work. I'm a little stuck here. Oh, not worries. 17 minutes. Do I have a hint? Discussion. Similar question, related topic. Solution to what is the trick here? What if I multiply this first one by 1, multiply everything by 2? By 2, multiply. Can I use complements? No, I cannot use complements in this case because it's not subtraction. Instead of subtraction, I'm supposed to do addition. Subtraction, I'm supposed to do multiplication. I need to multiply the entire array. Obviously, if I could use division, right? Let's think about it this way. If I could use division, if I could use division, right, I would have a nums equals to 1, 2, 3, 4. Then I have a nums copy, right? Essentially the same thing. And then what I will do is I will in fact simply do multiply this throughout the entire array, right? So just go ahead and do this. Just multiply, iterate and multiply. So for example, when I'm at nums 1, I will multiply an entire array by 1, and nums 2, I'll multiply an entire array by 2, and then nums 3, same thing, right? So that's that. And then once I'm done, I will just divide the entire array by this value on the respective indexes, and yeah, I will be done by then. But I cannot use division, right? Okay, I think that's about it. I didn't really get the solution, so I will go ahead and take a look at the answer. Maybe this one. Yep. Okay, so the first thing is we can loop through the complete array using a pointer. Multiply, accept this, skip on squared. Yeah, essentially what I got there. Dividing the product of array with a number. What I'll do is find the product of array numbers. Product of all numbers in an array, and then divide the product of each element of array to get an element. Ah, this is great. Yeah, but I didn't think of this. So essentially, if you have 1, 2, 3, 4, right, and then you multiply the entire array. Sorry, my answer actually was bad. It's still on squared answer. But essentially, if you have 1 times 2 times 3 times 4, which is 24, and you have 24, and then you divide it by 24 divided by 1, 24 divided by 2, 24 divided by 3, 24 divided by 4. And you will essentially get the answer that you want, right? Yeah. But you can't do this when you have 0, right? And the time complexity will be O(n), and they specifically mention that you cannot do division, right? Similar to finding a prefix sum array, we will need to find a prefix product array and suffix product array for original array. We will have to find a prefix product array and suffix product array for original array, i.e. pi equals I minus 1 times a minus 1. Yes, we multiply with a I minus 1 and suffix equals to suffix. So now index I, our final answer I will probably give him I. This prefix and suffix I. Why? Because pre times I every element before I, and every element after I will not be the element at index I. I don't get this, but let's see. Alright, so you have nums, you have new int of n, prefix of 0 is 1, suffix of n minus 1 is 1 again, and then you iterate through the entire prefix array. You want prefix iterate from I 0, you increment this, and essentially from okay Okay, essentially you form an array of prefix and suffixes. Then you have the prefix array that is goes by here, and then you have multiplies everything before it, and okay, you start with prefix 1 and suffix here I equals n minus 2, suffix of I equals to suffix of I plus 1 times suffix of I plus 1. Essentially the answer is a new essentially we have a suffix of I. Okay, you iterate it backwards, right? And then you multiply This is so difficult to understand. You have this prefix I, you start at 0, right? You start at 1, and then your prefix at 1 is equals to prefix of I minus 1, which is 0, right? 0 times nums of 0, 1 times 1. When you move on to here, you have prefix of 2. Finding the prefix sum array. Here we intend to find prefix product array and suffix product array. Okay, I essentially understand this. So essentially we are getting all the products so essentially when you have nums, right, 3 prefix will be 1, 2, 3, 4. You have you initialize with 1, and then prefix of 2 trace this algorithm here. Right, prefix of 1. Essentially here you trace this algorithm, you will have I equals to 1, prefix of 1, index 1 is equals to prefix of this 1 multiplied by prefix nums of 0. Don't get it. Prefix of this one is equals to prefix of the previous one, 1 times this 2. Prefix of this last one is equals to this times this 6, and then your suffix, right? Essentially suffix is you initialize it as 1, 1, 1. This one is done in this line, right? And then you iterate from n minus 2, which is here, all the way to the first value. So you start off when I equals to 1, suffix equals to this, right? N minus 2 is equals to suffix of I plus 1. This one, this value, times nums I plus 1, which is 6. Okay, this is 6. and then since you have 6 here, we move on to this value is essentially 6 times this is index 2 suffix of index 1 is equals to suffix of 2, this times nums 2, which is this 12, and then you come here finally, suffix of 0 equals to suffix of 1 times nums of 1. Times 1. Hey, sorry. Let's redo this. So essentially we have 1, 1, and 1. And then since we have suffix of 1, 1, 1, we look at this again. We start off from here. This value, suffix of, okay, when I is 2, right? We have 2 is equals 0, 1, 2, 3. It's 2. Four. This is 4. And then you look at this. This is 4 times 3 here. Right? 12. Look at this. 24. And then eventually when you multiply these two values together, prefix and suffix, 24, 12, 8 and 6. Is that the answer? Yes. How the heck do we even... Wow, I'm stunned. Okay. So let's take a look at this again. Directly store the product of prefix and suffix in the final answer array. We don't need to separate array to store prefix product and suffix products. We can do all the approach discussed in method 3 directly into our final array. So we look at this, right? We have an answer array and we fill the answer array with 1. Okay, the current is 1. And then for all elements in the array, we want to fill our answer with current. We want to fill our answer at the index I multiplied by the current. Okay, and then the current you want to multiply it by nums I. Oh, okay. What? Okay, so you multiply your answer array that's initialized to 1 by current. The first loop current will be 1, and then the next loop current will be multiplied by your nums I, right? Your current index. So in this case 1, 2, 3, 4, current will be 1 again. So you multiply 2 by 1 again, and nothing happens, right? And then your right, you have nums equals to like that. Okay, and then you have your current equals to 1. You loop through the entire array 1, and then you have your answer array, right? And then your first loop of this, right, you want to multiply your answer 0 equals to current, multiply this by this 1, right? and nothing happens. Okay, the next loop, when it comes to here, right, it will come here and it will multiply 1 by 1 again, so nothing happens. But however, at the end of this loop, right, at the end of this loop, your thing will be 2, and then you want to multiply your answer I, answer 2 times current, which is current, which is 2. Oh damn it, let's trace this algorithm. We have nums equals 1 2 3 4, answer equals 1 1 1 1, and then we have index I equals to 0, I equals to 0, right? So I is here, we're looking at this and this. I equals to 0, current equals to 1, right? Then you look at answer 1, answer 0, multiply by current, which is 1, nothing happens. Your current now multiply by nums I, which is this, nothing. Okay, so next thing, I becomes 1, and then nums 1, answer of 1, you multiply by current, which is still 1, so nothing happens, right? You move on. I equals to 2, here's where it's tricky. I equals to 2, you multiply your answer 2, index 2, by current is equals to 2, right? Answer 2 answer 2 multiplied by current equals 1. When I equals to 2, your answer 2 multiplied by current. Current is still 1, so this is still 1, right? And then essentially your current finally becomes multiplied by I, you get 3. Shit. Okay, let's try again. I equals to 2, current equals to 3. I equals to 2, current equals to 3. Okay, let's start again. I equals to 0. Let's just do this, okay? 1. Okay, let's do some manual tracing. So when we look at I equals to 0, okay, current equals to 1, right? So your answer at index 0, you multiply by current, nothing happens, right? Multiply by this, nothing happens. And then your current will multiply by nums I. Your current will multiply by nums I, which is this, nothing happens, right? Let's do one more. Nums I. One. Nothing, right? When you have I equals to 1, you have your current equals to 3. When I equals to 1, you want your answer in this array multiplied by current. Current is still 1, right? This time this is still 1, so nothing happens. Now you want to multiply your current by 1 times 2 equals 2. Okay? Cool. And then once we have 2, we go to the next loop. Now your current is equals to 2. What you want to do now is with 2, you want to multiply I1 times 2. So this becomes 2. And then this becomes 2 times 3. It's 2 times 3. Yeah, this becomes 2 times 3. It's 2 times 3. Nums 2. Six. Okay, and then I equals to 3, you get this 6. And you reset your current to 1, and then essentially for here you repeat this process but in the opposite direction. Multiply everything. Man, I'm totally mind blown, totally lost at why this is so. Okay, oh well. I think we have reached the 45 minutes mark, so I will take a look and study this question by myself offline, and that will be all for today.